great pleasure to have this presentation today. Actually, last year I visited Biomes and Biocontrol, and I understand we have a lot to speak, and I'm very glad that we have this opportunity. And 2 years ago, on another World Biostimulants Congress, we also had a presentation, but 10 minutes, so I'm very happy. Now I have a little bit more. So as always, I want to show you a lot. To start with, let me say a few words about the BTU. So BTU is a Ukrainian factory which is 25 years old. We have more than 500 people inside. We work in 3 businesses, mainly products for agriculture, but also we have some medical care products and also some for oil industry, for example, soil bioremediation. So in general, we have more than 60 products. Up to 10 of them are already represented in different EU countries. We have an office in Germany as well. In general, we work in nearly 20 countries, mainly in Europe. And we do, our focus is work on extensive crops like cereals, corn, and soybeans, rapeseed, etc. So our main experience goes there. And we apply our products on millions of hectares, so we work in a big scale, but we believe that it's the only way to really make a difference in agriculture, in soil health globally. So to get confidence in efficiency of our biologicals, we do thousands of trials, some of which you will see today, not all 2000, don't be afraid. We will speak about a few global challenges today. So I will say a few words about the solutions I will represent today, just for you to understand what is speaking about. So first is Ecostern. Ecostern is a complex of bacteria and fungi which we apply first of all to accelerate the composition of plant residues, and we study this product in regenerative farming, in recovery of polluted, flooded land or other let's say soil which need our microbial help. Another solution is GroundFix. It's a phosphorus solubilizer. First of all, it's a complex of bacteria which can improve phosphorus availability in soil and rhizosphere. Third one is AzotoHelp. AzotoHelp is a nitrogen fixing bacteria which we apply both foliarly and into the soil, but which also help plants to grow in stressful conditions. So a few examples you can see here or in the poster area. Liposome is organic adjuvant produced by bacteria, and also which also have anti-stress functions. But today in my presentation we will speak mainly about soil. So to speak about soil, we should understand what is soil actually and what is soil health. So this is a definition which is about the sustainability in agriculture, because if you want to keep your soil healthy, you need to keep it functional in both chemical, physical and biological directions. So we will review a few studies when we use biologicals and how we influence these soil health parameters. So let's start from carbon and Ecostern. So you can see here the study, which is actually more or less 6-7 years ago. It was made by an independent scientist in the institute. She wanted to check if we accelerate the composition of plant residues, either we increase carbon evaporation. So first of all, she made assessment of CO2 evaporation into the air to see if there is a significant difference when we accelerate this process or not. So her finding was that really application of in Ukraine we call it biodestructors or biodecomposers does not increase carbon evaporation. So where this carbon goes? So she continued the study to analyze what happens in the soil, first of all in organic compounds in soil. So she analyzed the total humus content in the substrates, and there was a slight increase, in this case almost 5%, to this figure, and also she analyzed the labile organic compounds in soil substrates, as it more quickly reacts to any actions concerned with soil. So in both cases she catch positive dynamics in organic matter accumulation, and this gives her and us more confidence that really application of biofertilizers and ecostern can have positive influence in carbon sequestration. Other questions were to see how it goes on different soil types. So we started to analyze in three soil types: podzolic soil, dark grey soil, and chernozem. And we find out that yes, the composition of plant residues goes with different speed on different kind of soil. But in each case, if you help with microbials, it proceeds quicker. Second thing is how this process influences soil density, because in some regions, for example in Kazakhstan or in some other areas, soil density is quite critical. So we find out if we enrich soil with organic matter with use of biological fertilizers, it also have a positive influence on soil density. Besides that, you can see that we have another study over here, which is more than 10 years old already, so we really started with these directions quite a long time ago. We studied again it was a specific project, how during like 4 or 5 years we could increase organic matter in soil. So they use also some siderates and green manure to accelerate this process. And what we find out again is that when we used ecostern in this technology, process of organic matter accumulation goes faster. And this is very important and quite recent data, which shared with us our partner Kernel. I also want to thank Arkady Lungul and Michael Jourba, who shared with us this data. So Kernel, company name over here, is a Ukrainian leading farmer who has more than 500,000 hectares in total, so it's quite a big farm. And they use ecostern in their technology for more than 10 years already. And they do a lot of, they have their own scientific station, and they do a lot of research, quite deep. And they are one of the leading farmers in Ukraine who implement biological solutions in a large scale. So what they looked for, as well as they incorporate ecostern to their technologies, they wanted to see how it influences organic matter accumulation in soil. So after 3 years project study, they find out that on control it was just water. Here they use just urea ammonium nitrate, and in this variant they use different forms of ecostern together with urea ammonium nitrate. So what they find out is that there is a clear positive tendency to increase accumulation of labile organic matter in soil when ecostern is used together with urea ammonium nitrate. Also, they looked on additional parameters, as for example micromycetes balance in the soil. So what we see in the first column, is that when you use nitrogen to soil, logically you provoke micromycetes to grow, so you have more fungi in your soil. But when you use ecostern, or when you use biological fertilizers containing bacterium fungi, trichoderma first of all, you also increase the amount of trichoderma in soil. And it's interesting that in all variants where ecostern was applied, we can see the increase of trichoderma amount in the soil. So soil is more functional. Then we do really thousands of soil samples, to analyze it in a complex way, agrochemistry as everybody do, but also some biological things. And what we find out that we select some 55 representative trials, and we find out that in more than nearly 65% of cases, we can observe increase of amount of micromycets in soil after application of EcoStern. And in average, increase was up to 45–50%. And what is also important that this increase is first of all in saprophytes group, so we don't provoke wrong microbes. Also, recently, last 2 years, we studied new methods of soil analysis, that is Biocontrol&Biomes, Japanese technology, to assess soil enzymatic activeness. And what it shows, so there are such plates and with different sources of carbon and other substances, and they dissolve soil in water and put on this place, and they see how active, how rich is microbiological compound of soil, which decomposes different carbon sources. And they have this kind of scale to assess the level of activeness or health of soil, depending on how actively they decompose these sources. So what we started from, they actually that was their initiative. They took a sterile soil, so the Biocontrol&Biomes metric for sterile soil was near close to 0. And when they treat soil with industrial dosage of EcoStern, they succeed almost to recover enzymatic activeness of soil to normal indicator. And this gives us a big inspiration together to proceed with our studies to the fields. So next year also we do again a lot of studies, and this one was from Germany trial stations. So we had here normal control with 100% fertilizer, and one with EcoStern applied above on the top of the scheme. And in this case we succeed to increase this soil enzymatic activeness up to nearly 10%. Also, we had another variant with 75% fertilization and with a complex of biofertilizers, and in this case, this activeness of soil improved even more. And one of the very recent studies, as I said, we work with a lot of regenerative organizations. This one is from Germany. And together with them we study incorporation of EcoStern to regenerative practices of farms. But how to assess what actually EcoStern provides to this technology? So we used EcoStern to see what's happening in the soil. So what we find out that from the two fields, on the one field we increased Biocontrol&Biomes metrics almost for 30%. On the second field, when we applied EcoStern, we increased it nearly 10%. And what also is valuable, we increase not only activeness of soil microorganisms, but also ecophysiological biodiversity, which means that after application of EcoStern, microbiome of this soil could cope with more sources of carbon. So we believe, and we continue such studies not only in Germany, that EcoStern and biofertilizers could play an important role in regenerative agriculture. So don't be afraid of such a big table, but I just wanted to show our complex approach to soil analysis. So when, in this case, we applied EcoStern and ground fix into fertigation in the garden. In the garden it's also quite difficult to catch difference in the yield, for example, so we need some instrument to value if product worked or no. So in this case we analyzed agrochemistry first of all, because we were looking for better phosphorus availability, and we catch it. So on the variant B, where we applied these biofertilizers, there was more available phosphorus as well as potassium in the soil. Also we observed a positive change in amount of micromycets in the soil, first of all in trichoderma, which is a compound of EcoStern. And also we observed a bigger amount of bacteria in the soil. And more practical case, we do have a lot of trials already to compensate some amount of NPK with biofertilizers. So in this case, we studied ground fix, which is our phosphorus solubilizer based on bacteria, and we on the field with corn decreased the amount of fertilization for 30%. And what was interesting in this study is that with incorporation of ground fix into this decreased dosage fertilization scheme, we reach yield which was even higher than on 100% fertilization scheme. And not only on corn, we also have such studies in sunflower from the recent year. And here we used phosphorus solubilizer ground fix together with azotohel, and with 30% less fertilizer than on control. So if we compare this variant with 100% fertilizers and variant with 30% less, but with these biological fertilizers, ground fix and azotohel, we even reach higher yield than on this scheme. We also study just in adding of biofertilizers to normal traditional scheme, and you can also see that potential of biofertilizers is higher when you play a little bit with fertilizers. Yeah, so sometimes our partners experiment even more than we recommend to them, because we say like 15-20% is okay, but in this case our partner tested 160 kilos of urea decrease on the corn scheme. But interesting finding was that even in this decrease of nitrogen, the yield when nitrogen fixing product azotohel was applied was even higher than on 100% nitrogen control. I will accelerate. And just another example on the soybeans from Serbia, where we used almost 140% less kilos per hectare fertilizer and reach even better yields than on control with all fertilization scheme. Just as a kind of summary, we have a really great amount of trials with biofertilizers with different functions. They're quite highly efficient with 80-90% of success rate. We already apply them on millions of hectares, so it's not something working just in lab. And what is very important, you don't only invest into your soil, but you get the short-term income as well, because normally you get the growth of yield which overcome your investment at least a few times. So on that, I would like to thank you for attention. Also, we have a poster in poster 75 about the drought tolerance and abiotic stress tolerance with use of microbials. So I invite you to visit it. So thank you for your attention, and we'll be glad to answer your questions.
Thank you very much, Dimitro. Do we have any questions from the audience? Yes, we have one back here. If you could use the microphone, please.
Thank you for your presentation, very nice. I was wondering if you have also data on the efficacy of this, if by using these products you also see efficacy on the control of pests or diseases.
We work with both biofertilizers and biopesticides, and we prefer to differentiate this or divide these groups. So on these kind of products, we focus on fertilizing properties. And if we talk about some biocontrol agents, which we also work with, for example, against Sclerotinia, then we look directly at what we do with that problems.
I have a question. How quickly after application do you see the changes that you're measuring and reporting here?
Very good question, which actually is in our I'd say pipeline of answering, because even now at the moment with Biotrax we do some trials to analyze what we can find out in 1 week, 2 weeks, 1 month, 2 months, to catch what is the best moment to see efficacy of biologicals. But in terms of our agrochemistry, normally we observe, I'd say, like we need to control like before application of the product, and we normally observe what is the situation on the peak of vegetation. And how to say, not absorption, but consumption of nutrients by plant, and we also analyze the end of the season, like before or after harvesting.
And sort of a follow-up question, do you see additive benefits if you apply year after year with your products?
Yes, we do. Actually, we have one even finding that our partners ask us not to mention, because, for example, when we apply ground fix with this phosphorus-solubilizing bacteria, we observe that even the second season there is a positive after effect of this product. But I say, okay, not say it because I will not use it each year. But still, of course, it's how to say, it's a kind of philosophy. Some of our clients, even big ones, even this kernel, say that after like 5-6 years of implementation of EcoStern into the technology, the field even smells differently. But of course there is a change in properties, structure, and yeah, so of course long-term application is good for the soil health.
Great. Any other? Yep, we have another question there in the back.
One question regarding where have you tracked your microorganisms, where they stay, only in soil or as well in the plant, and how they affect the plant from the soil, from the roots plant?
If I understand your question right, I would say so. So we have a practice of application of biological spores into soil and foliarly, and microorganisms produce a lot of metabolites which are growth promoting, like phytohormones or amino acids or some other substances. This is one way. But second way, also we study possibility of microbes, endophytic microbes, which can penetrate plant and produce something more. And this is perspective directions which we continue to study. Hope I answer your question.
Okay, thank you very much. We now have a networking break from now until 4:25.